and welcome to the podcast where friends discuss environmental policies from around the planet.
Hello, here we are with our first episode from our Series 3 break.
That's not really a break.
I'm Adra. I'm joined here with my co-host who likes to talk before her place.
Wow.
Please introduce yourself, woman.
Hi, you guys.
Clearly, no introduction necessary. But about the break, it's a 3-week break. We will still be putting out extra policy episodes every week, so please be sure to catch them. And today, for our first episode, we are talking about the Australian blob that is worsening mega droughts around the world. Now, where did it come from? Well, Ala's boyfriend sent us a news link like a month ago, and then both of us, of course, went down a rabbit hole about this study.
Of course.
As one does. So here we are trying to talk about it, and we really hope that we can explain this. So this is going to have a lot of scientific stuff and a lot of background, so I really hope that we do justice to it.
Yeah.
So, what is this blob and where is it? Well, it's an unusually warm patch of water that is situated east of Australia and New Zealand, and experts believe it is triggering ongoing droughts around the world. Now, it is believed to have emerged in the southwestern Pacific Ocean about 40 years ago, so it's been around for a while.
Yeah.
And it takes up about 3% of the South Pacific.
That's pretty big, right? Because that's a big ocean.
Yeah, and 40 years ago, so of course it's not a coincidence that around the time that it supposedly formed, more and more climate scientists started noticing the effects of global warming. So,
Wow.
it was already hint.
Look at the coinkydink.
Yep. So, what happens? Why do we get these blobs? So, this is not unusual. Blobs happen around the world in the oceans. They happen. It's just when there's a lot of direct sunlight, not enough winds for the surface of the water to mix in with the rest of the ocean. They form up, they go away after a couple of years. But this one has been around for 40 years. So, of course, it's a matter of concern. So, what do the scientists say about it? Why is it there? So, it is, of course, likely caused by a naturally occurring decline that happened over the naturally occurring decline in rainfall that happened over the central tropical Pacific. Now, this drop in rainfall affected atmospheric circulation in the region, and it created wind patterns that changed how warm or cold currents flow in the ocean, and it guided more warm water to the blob while pushing cold water deep down. Now, the warm surface water that makes up the blob then heats the air above it, and as the atmosphere warms, it expands into a big, broad area of high pressure, which is called the high pressure ridge.
Yeah, and we're going to talk about that ridge more.
Yeah. So, drought and decreased precipitation, they're common side effects of climate change, we know that, but especially in notoriously hotter and drier areas, it's even worse. And while the blob was caused by hot temperature and drought, it's actually exacerbating droughts in countries thousands of miles away.
I don't know, like, this story is crazy to me because one thing all the way off the coast of Australia and New Zealand is changing lives so far away. I don't know, it's just so crazy.
Yeah, so we're going to talk about why it's doing that. So how does it spread and why is it bad? So basically, during the last 4 years, the sea level pressure has been decreasing over the Emerson-Bellinghausen Sea.
Ooh, look at you with the pronunciations.
Oh, thanks. So the pressure has been increasing between New Zealand and Chile. And this created pressure dipoles across the South Pacific, right? So there's more high pressure and more low pressure. The extremes are getting worse. Now, the trends are usually strongest during winter in the southern hemisphere, and they influence the climate of West Antarctica and South America. Recently, these pressure trends have been, the reason why they say it, it's because of the variability in the tropics that has happened over the decades and the expansion of the Hadley cell. So what's the Hadley cell? Guys, I actually watched like a bunch of videos to learn this, so I really hope that I'm doing a good job at it. So to explain it, it's that there's this intense heating that happens by the sun at the equator because, of course, we know the curvature of the earth. The sun is affecting the most at the equator, which leads to the hot air rising because, of course, it's less dense. Hot air rises to the north, and then gradually it sinks, which creates these circles of air that are called the Hadley cells.
Go on, meteorologist Ajwa.
Thanks. And then we also saw an associated positive trend of the southern annular mode, which is SAM. Now, what is the SAM? This is also something that I watched a few lectures for. So it's basically what drives climate change in Australia. Now, how does it do it? So there's a strong pressure belt in the southern hemisphere, which is called the subtropical ridge. On the southern side of this ridge, there are these westerly winds, which sailors in the olden times used to call them the roaring 40s and the furious 50s, and then there was another one that sometimes they'd call the shrieking 60s, but that's not as common. Yeah, because they move between the latitudes of 40 and 50 degrees south.
Okay.
So that's how they associated like how bad the winds are going to be, because of course sailors have to care for winds in the ocean. So of course when they move, it causes changes in the climate around the southern hemisphere, and when it moves towards the south and away from Australia, it is called a positive trend, and that's what we've been noticing, right? So when it moves away from Australia, it means it's also moving away from South America because they're all in the southern hemisphere. But these mechanisms explain only about half of the pressure trend intensity that we've seen. Now, there were experiments that they conducted with 2 atmospheric models that indicated upper ocean warming over the subtropical Southwest Pacific. That's basically what they term the southern blob. And this accounts for about half of the negative pressure trend in this region and all the ridging and drawing that has happened over the eastern subtropical South Pacific. So this is also because of the blob. So it contributes to the central Chile mega drought. However, so the current warming rate, it exceeds the range of what we've seen the natural variability to be, which of course implies that there's an additional anthropogenic contribution, because of course, how can humans exist and not impact the climate?
Of course.
Now, because of the shifts, it causes warmer air to move towards the Antarctic, and it has caused a reduction in the Antarctic sea ice, which in turn threatens the region's delicate ecosystems, and they have far-reaching consequences in altering global weather patterns, as we've seen recently. One of the most fascinating things about this is that we have this human-caused signal in the climate system that is sitting in the middle of nowhere. But because of the way the ocean circulates, it has the ability to influence regional climates where huge amounts of people live. And it could be like tens of thousands of kilometers away, which Allah is going to explain to us where it's happening and what it's doing.
Yeah, it's pretty crazy. Like, it's wild to me. I will never get over this. So mostly we're going to talk about the mega droughts in Chile, but just keep in mind that other South American countries have been affected by this drought. So Chile is in the southern hemisphere, and like Ajwa said, when this blob thing happens, there's just a lot of winds that are shifting towards the southern hemisphere instead. So Chile used to have its winter months in July and August, but the weather hasn't shown the typical signs of winter in quite a while. There's lack of precipitation this year specifically, and it has left what used to be towering snow-capped Andes mountains above the city mostly bare. Their water reservoir levels are low, and a lot of the farm fields are parched. So while Chile has been going through this drought for the past decade, July, like I said, was like super dry, and August as well. As of the end of July this year, Chile had 78 millimeters of rainfall, which was down from 180 millimeters at this time last year.
Oh, wow.
Yeah, I know. A recent report by the IPCC, which we will cover next week, said that as temperature rises, droughts are becoming more frequent, and like I just said, human activity is to blame for this uptick in the frequency of droughts. In fact, 2 rivers that provide the city of Santiago with water, the Mapocho and the Maipo, are drier than they were in 2019. It's the driest year in Chile's history, you guys. It's becoming a problem. They talk about something called Day Zero in the articles I've read. And this is just like the day that they believe that taps will run dry in certain communities, and then they will have serious water restrictions. But Day Zero has already come for certain places in Cape Town, South Africa, and in Chennai, India in recent years. Residents had to have water shipped in. And in fact, I believe this also happened in this town in Colorado, because I saw a video about it and I can't remember the name right now. Almost a decade ago, for nearly 400,000 people in the rural areas of Chile, those people needed to have water shipped in on trucks for them as well. It's just becoming a whole issue. And the article I read referenced this guy called Raul Cordero, who works at the University of Santiago as a climatologist. So, yeah, they haven't faced day zero yet, but things are getting dire. So we need to pay attention. So again, Adjoa talked about, the way the system works. So let's talk about how it's really connected to the blob. These droughts are. On the surface, they have nothing to do with each other because they're so far away. But the study that Adjoa mentioned, they found like these forces of atmospheric pressure and circulation are what's causing it. You know what I mean? And like Adjoa said, over time, this blob has just gotten bigger and hotter and hotter. So according to the study that was published in the Journal of Climate, the heat from the southern blob warms the air directly above it, and then it carries that warm air to South American countries. So that's what's happening. All this warm air is being pushed. And at first I was thinking like warm air is going to be humid, but that's not what's happening. The drop in rainfall that affects the atmospheric circulation in the region also creates wind patterns that change how warm and cold currents flow in the ocean. So more warm water is going to the blob, and like Adjoa said, the cold water is going down. And that heated air is what is getting there. And it's just not carrying moisture with it. It's just hot, dry, gross air. And this big, broad area of high pressure, which is known as a high pressure ridge, the ridge that we mentioned, that is what's going all the way to Chile. And I forgot to say, but the study was done at the Victoria University of Wellington. So another thing that this big ridge does is that it blocks storm systems that bring rainfall. So that's the biggest problem with it. Apart from carrying that warm air over there, it has such a huge force that you can't have storm systems. And so you're not getting rain. And when the scientists took the blob out of those bottles that they created, that Adjoa mentioned, they found that the ridge of high pressure totally disappeared. So if the blob did not exist, this high pressure system would not exist. Because sometimes you can have correlation in science, but it doesn't necessarily mean causation. But the model doing that provided causation. That's how they know that they are linked. Right now, because of this system, storms have shifted south towards Antarctica, and they're moving away from places like Chile, Argentina, and parts of the Andes Mountains. And those places really need these winter storms because that's how they replenish their freshwater reservoirs before their dry season. But if the reservoirs aren't getting replenished year after year, it's going to keep drying out. And the thing is, you guys, we know global warming is a problem. Almost every episode in this podcast, we talk about climate change. We have to talk about it. But because the blob keeps growing, the situation in Chile gets worse. And part of the reason for the blob continue to grow is, you guessed it, global warming. So it's just like one continuous unending thing, right? The high pressure ridge is there, the storms get pushed away, the area is still drying, nothing is getting replenished. And it's just a cycle that just keeps going on. And in fact, during the winter season, in the southern hemisphere, over in Chile, the blob that's over there in Australia in the northern hemisphere warms about 3 times faster than the global average in other parts of the ocean. So it's making the situation even worse. And since the dry season comes right after the winter in Chile, that means that they're getting no rain before, it's super dry, and then it's going to be extra dry again because that's the regular weather pattern. And like she mentioned, Antarctica and how the warm air is being pushed towards there. So obviously sea ice, and the reason it's going to affect global weather patterns is because the ice is melting. And we all know you do not want the Antarctic to keep melting.
In case you don't know, keep up.
Unfortunately, you guys, we're not ending this episode with here's a good thing that came out of it. We just don't have a good thing to report because they're not sure how the blob will dissipate. And the blob is not shrinking, you guys. That blob is like, I am here. This is me. Hear me roar. I am blob. I don't know. It's not going away. But yeah, that's the gist of it. Fascinating, but kind of sad. An organization that we'd like you guys to check out is called AGRID. They're the Chilean Association of Irrigation and Drainage. They've been supporting agribusinesses for 12 years in the implementation of good practices for the use of water and energy, considering that they have a water problem. They bring together large numbers of companies and professionals from Chile and abroad, and their purpose is to contribute to the efficient use of water and energy. They're the only union like that in that region, and so far, they've helped to install more than 90% of new irrigation infrastructure in Chile. Question for you guys though, this entire report is about how seemingly unrelated events affect each other. So with that said, can you guys think of any other situations where a climate change event in one area is causing another event in a far away area? Let us know, we'd really like to know. Thank you for joining us on this extra policy discussion. We're still on our mini almost break situation, but not really. And next week we will discuss takeaways from the recently released Working Group 1 findings of the IPCC 6th assessment report. What does it mean for the future of our climate? Well, find out next week. Follow us on Twitter, Planet Policy Pal, Instagram, Planet Policy Pals, and like our Facebook page. We are still on this little social media break thing. Honestly, this break is mostly about us just taking a break from social media, to be honest. That's what we do when we take these breaks, because we still give you episodes.
Yep.
So leave us a comment, message us. We will get in touch with you. And until next time,
Keep learning, pal.